Hi, today we're going to be learning how to calculate the surface area and volume of rectangular prisms when missing a side length. So we're going to be taking a look at two different ways to solve for the surface area and volume of this rectangular pyramid. If you'd like to see the method involving these formulas and how to apply them, feel free to skip ahead. So let's go ahead and start off with our surface area. For this, we're going to label all 5 sides of our pyramid. So I'm going to start with the bottom. I also have the front and the back. So front, back, and then these 2 sides on the side, and then the other side. So let's go ahead and start off with our bottom rectangular side. So dimensions are 18 by 12, so we're going to do 18 times 12, and that's going to get me 216. Let's do the front and the back next. So the front side is a triangle, which means we're going to do 1/2 times base, which is 18, times the height of the triangle, which is 16. All of that multiplied is going to get me 144. If the front is 144, that means the back is 144 as well. Okay, now let's move on to the right and the left sides. Again, both of these are triangles, so we're going to start off with 1/2 times the base of the triangle, which is 12, times the height of the triangle, which is 17. And all of this is going to get me 102, and that's for the other side as well. If I add all 5 sides together, I end up getting 708, and our units are going to be feet squared. And that's the surface area. For the volume, we're going to start with 1/3 times the area of the base or the bottom, which we got 216. And then we want to multiply it by the height of the pyramid. But notice that in this case, we do not have the height given to us already, which means we're going to need to solve for it. So to do that, I'm going to go ahead and find the center of my rectangular base and then connect to the top of the pyramid. So here's the height of the pyramid. I'm also going to draw a line down the slanted height of this pyramid and then connect the two. So notice that it makes this right triangle. So I'm going to draw the right triangle down here so it's easier to see. I know that the slanted part of my triangle is going to be this right here, 17. I know that this vertical part is what we're trying to solve for, the height. And I also know that this part down here at the bottom is going to be half of whatever this length right here is. So I know that this is 18. Half of 18 is going to get me 9. To solve for this missing side, I'm going to use Pythagorean theorem. So let's start by labeling my A, B, and C. So across from my right angle is going to be my C. And let's just say this is A and then this is B. So let's plug that into a squared plus b squared equals c squared. So a squared is just going to remain the same. A squared plus b squared is going to be 9 squared equals my c squared is going to be 17 squared. So that leaves me with a squared plus 9 squared is going to get me 81 is equal to 17 squared is going to get me 289. I want to get a squared by itself, so let's subtract 81 from both sides. This now cancels out and I'm left with a squared is equal to 208. And when I take the square root of both sides, I end up getting a is equal to 14.4. And this is just rounded to the nearest tenth. So what we solved for was this height of the pyramid, and we're just going to go ahead and label this 14.4 feet. And this is what we're going to be multiplying here to find the volume. So I'm going to be multiplying this by 14.4. All of this multiplied is going to get me 1036.8 feet cubed. And that's the volume. All right, now let's try applying these formulas over here. So we're going to start off with surface area, and I want to label each of my dimensions. So we're going to say this length right here is our L, and that's going to be the full 18. This length right here is going to be our width. And then these two slanted lengths are going to be the slant heights. So here I have slant height 1, S1. Here is S2. And now we have enough information to plug it in. So we're starting with length times width. So that's 18 times 12. So 18 times 12 plus length times S1. So that's going to be 18 times 16. 18 times 16. And then add that to width times S2. So that's going to be 12 times 17. 12 times 17. Let's simplify. 18 times 12 gets me to 16, plus 18 times 16 gets me to 88, plus 12 times 17 gets me to 04. And all three of these added together gets me 708 feet squared as well. So there's my surface area. For the volume, we're going to start with 1/3, and we're going to multiply it by length times width times height. Now for the height, remember that we figured out the height by using the Pythagorean theorem here, and we got 14.4. So if I multiply all my dimensions together, that's going to be length 18 times width 12 times height 14.4. And all of these multiplied is going to get me 1,036.8 feet cubed as well. So there's the volume. All right, now let's try solving for this rectangular pyramid. This one's going to be a little bit different. So again, we're going to be starting off with surface area. And I'm going to label all my 5 sides. So we're doing the bottom, then the front, then back, and my 2 sides. Okay, starting off with our rectangular bottom, I have dimensions 8 by 5, so we're going to do 8 times 5. That gets us 40 for the bottom. Now let's try solving for the area of this front triangle. So notice that I have the base of my triangle, which is 8, but I do not have the height of the triangle. The 12 meters is actually the height of the pyramid, not of this front triangle. So I'm missing the slanted height. I'm going to go ahead and draw it out for you here. So starting from the top, I'm just going to draw a line connecting it to the base of this triangle. I'm also going to draw a line down the height of the pyramid, and then connecting these two, notice that it also makes another right triangle, just flipped in a different way. So I'm going to draw out here for you to better see. So here's my right triangle. I know that this vertical height right here is 12, right? Right here was our 12. This slanted part is what we're trying to solve for. And then what is this base down here? If I want to solve for the length down here, I need to take a look at my picture again. So notice that this base and this base are both parallel to each other. I know that this is the full length, whereas this is only halfway. So to figure out what this is, I need to take half of 5. So half of 5 is going to get me 2.5. And that's the length right here. Now let's solve for the slanted height. To do that, we're going to use Pythagorean theorem. So let's start by labeling our A, B, and C. So across from our right angle is going to be our C. Doesn't really matter which one's A and B. So let's just say there. We're going to plug it into A squared plus B squared equals C squared. So starting off with A squared, that's going to be 12 squared, plus B squared, which is 2.5 squared, is equal to C squared. To solve, 12 squared is going to get me 144, plus 2.5 squared is going to get me 6.25, is equal to C squared. Adding 144 plus 6.25 is going to get me 150.25, is equal to C squared. And then I want a square root to get rid of the square. So that leaves me with about 12.3 is equal to C. So what we just solved for was the slant height right here. So I'm going to label this 12.3 meters. And so now we have the height of our front triangle. Let's go ahead and solve for its area. So we're going to do 1/2 times the base of the triangle, which is 8, times the height of the triangle, which we just found, 12.3. All of this multiplied is going to get me 49.2. And that's the same for the back as well. Now let's solve for the area of this side triangle right here. So again, notice that I have the base of the triangle, but I do not have the height. So again, I'm going to draw it in. So here's the slant height, and connecting it to the actual height will get me this right triangle. I'm going to draw it down here for you to see. So here's my right triangle. Remember, the vertical height was 12. We're trying to solve for the slant height. And to get the length of the bottom part right here, we're going to take a look at which one is parallel to it. So in this case, it's going to be the 8. Half of 8 is going to get me 4, so that means this base right here is going to be 4. Again, we want to label our A, B, and C. So here's my C. Let's just say this is A and this is B. Plugging it into A squared plus B squared equals C squared. I start with A squared, which is 12 squared, plus B squared, which is 4 squared, is equal to C squared. 12 squared gets me 144, plus 4 squared gets me 16 is equal to C squared. 144 plus 16 is going to get me 160. This is equal to C squared. And square rooting both sides, I get approximately 12.6 is equal to C. So that means this slant height right here is going to be 12.6 meters. So if I want to solve for the area of this triangle, we're going to do 1/2 times the base of the triangle, which is 5, and we're using the full base. The height of the triangle is 12.6. And so if I multiply all of these together, that's going to get me 31.5. And that's the same for the other side area. Adding all 5 of my sides together is going to get me 201.4, and that's meters squared. So that's my surface area. Now for the volume, we're going to take 1/3 times the area of the base or the bottom, which is 40, and then multiply that by the height of the pyramid, which we did actually have from the very beginning. That was our 12. If I multiply all of these together, that gets me 160, and this is meters cubed. So that's the volume. Now let's try applying these formulas. So starting off with the surface area, I'm going to label all my dimensions. So this length right here, the full 8 is going to be our L. This length right here, the full length, again, is going to be our W. And then my slanted heights right here and right here are going to be S1, S2. Now let's plug it into the formula. So we're starting off with length times width. So that's 8 times 5. 8 times 5 plus L times S1. So that's 8 times 12.3. And then finally W times S2. So that's 5 times 12.6. Let's simplify. 8 times 5 is going to get me 40. Plus 8 times 12.3 is going to get me 98.4. Plus 5 times 12.6 is going to get me 63. Adding all of these together is again going to get me 201.4 meters squared. And that's the surface area. Now to do volume, we're going to do 1/3 times length times width times height. So remember the height right here was 12 initially. So we're going to plug all of our numbers in. So length was 8 times width was 5 times the height of 12. And all of these multiplied is going to get me 160 meters cubed as well. And that's how you solve for the surface area and volume of rectangular pyramids when missing a side length. Thank you so much for watching. Please like, subscribe, and comment with any questions or topics you'd like to see next. Bye!